George Whitesides is a world-renowned researcher and chemist. He's a pioneer known for leading innovative research in diverse disciplines of science, ranging from biochemistry to soft robotics. He's written nearly 1,000 research papers and holds more than 50 patents. Dr. Whitesides currently serves as a professor at Harvard University. Recently, his lab designed a revolutionary diagnostic test. A couple of things make it remarkable. First, it's as small as a postage stamp, and it costs as little as a penny. This new paper test has the potential to save thousands of lives and dollars by providing a streamlined and inexpensive solution to diagnostics in the developing world. Joining us now is Dr. George Whitesides. Welcome to Full Frame.
Pleasure to be here. Thank you.
It's great because I had a chance to visit with you a little bit, and you're not a guy who wants to spend a lot of time on the past. You'd rather talk about the future. But we'll start with the past. Your career has spanned, I'd say, a few years. Talk to me about that arc. How have things changed since when you began to today?
First, one should say it's a few decades. Let's put the perspective.
Trying to be generous.
Thank you very much. Things have changed a lot. When I started, which was the early 60s, we were just finishing with World War II. The Cold War was in operation. Much of technology was being developed basically in response to national security concerns, and there was the beginning of emergence of what we think about as medicine and healthcare now. So everything was at the beginning. We're now in a totally different world. And so science has gone from a focus in what I would say was physics and the early stages of information, increasingly to a focus in biology, life, healthcare, and things of that general sort.
So how have you had to adapt?
It's not a question of adapting. The wonderful thing about being in a university is you get to follow your nose in whatever happens to be interesting at the time. So I started my career thinking about catalysis for making fuels, and we're now thinking, among other things, about robots and origin of life and healthcare.
It's interesting. There's a key word that's out there right now, and I have to sort of laugh because it's in your field now. It was in our field a few years back. It's the word convergence. I can remember back in the late 90s, we're going to take this TV station, we're going to couple it with a newspaper and online, and it's just going to be the great new thing. And interesting to know, the newspaper that I was aligned with is now out of business. So hopefully your convergence goes better than the media's stab at this. But talk to me about convergence in your field. How has that changed the dynamic?
What convergence has, I think, increasingly come to mean is bringing together ideas from medicine, of course, what you used to think of as research biology, which might be, for example, genomics and immunology, the general issues of social engineering and the tools that they bring to help people understand health, technology of a wide variety of sorts, economics, which is an increasingly big deal, politics, that is how one distributes healthcare benefits across the world. All of these now have to be part of a common package. How we're going to make it work, I don't have a clue, but it's an interesting problem now.
Yeah, when I go back to convergence in my field, there was resistance towards convergence, where everyone seems to be siloed. Has that been an issue in your line of work?
Of course it's an issue, because one of our great virtues, particularly in the United States, is we have an ideology, and it's called capitalism. And capitalism is fantastically good at solving problems that have the potential for profit, and not quite so good in problems that have the potential for social benefit, but maybe not so much for profit. So the question of understanding how one puts together all of these desirable objectives and pays for them, that's a problem we haven't quite worked out yet.
But it's interesting. You and I were chatting about healthcare in the United States, and there's perception and reality. The perception is it's the greatest thing on the planet. Reality is something entirely different, isn't it?
The United States is in an odd situation now in that we believe that we have a wonderful healthcare system. If, in fact, you compare, and it's not I who's done this, the National Academy in one of its various incarnations has done a careful comparison of healthcare in the U.S. compared with healthcare in perhaps 20 other developed countries according to 20 metrics, and reached the conclusion that the United States is the most expensive and essentially the bottom or next to the bottom in essentially every metric. Now, why is that? It's a complicated story, and of course we are doing much of the research for the world, so that's a good thing, but we're also necessarily maybe thinking about it the wrong way.
How does it square with Cuba?
Well, Cuba is a country which has the characteristic that it has also a healthcare system that seems to work pretty well. The average lifespan in Cuba is about the same as the lifespan in the United States, taking that as a surrogate for healthcare, and it costs apparently almost nothing. So I don't know how you make that comparison other than to say they may be doing something that we should consider doing ourselves.
So when you think about a place like Harvard, where you're at, you think of thought leaders being there, and so thought leaders think a lot and talk a lot and kind of look at the future. So when you sit there with your colleagues and think and talk, what do you talk about? What do you think about?
You're very generous in your description of what goes on in the university. Yes, we do some of those things. The question is, what are we trying to do? And we have a model, particularly in healthcare, which says that every human life is beyond value. And so we spend an enormous amount of money keeping people alive at the end of their life. The question is that the right way of spending money? It's not that that's a bad thing to do, but one is always resource limited. So does one spend money throughout a lifespan to keep people healthy? Do you focus on children to give them the best possible start? Do you focus on the elderly? And I can represent this group now. Focus on the elderly and keeping them alive. And I don't think we have a plan for that other than the end of life turns out to be the most profitable part.
Paper chip technology. I saw your TED Talk on this, and I was blown away. I'm sure everybody in the audience was as well. Tell our audience about it.
The paper chip idea was the following, that when you go to much of the developing world, and developing is code for economically developing, which is countries that are still working their way up in the economic cycle. Culturally, they may be fine, they may have other virtues, but they're not necessarily rich. So you go to this part of the world, which is about 80% of the population of the globe, or 70% of the population of the globe, and you ask, is there an adequate healthcare system? And the answer is generally no. So one asks, what is a healthcare system? And there's a kind of progression, which I think is probably common everywhere. You feel bad, you go to a doctor, the doctor does some kind of diagnosis. Based on the diagnosis, you're treated, and if everything goes well, you get better. But that initial step of diagnostics is in one sense a minor part of the overall problem, but in the other it points the direction that the medical system is supposed to go, both in treating you and perhaps also in avoiding whatever it is that's making you sick. So our interest was, how do we develop diagnostic systems that can work in this economically constrained world? And a big part of that is they have to be inexpensive, they have to be workable in an environment where you don't have a lot of people who are highly trained and you don't have many resources, and it has to give information that's actionable, and it has to be affordable.
And one of the things I found striking about your presentation is it's simplistic, but clearly it's not. I mean, you have to spend a lot of time arriving at what you arrive at, and a lot of thought goes into it. Explain to me, if somebody's out in the field, let's say in Uganda or somewhere, and it's a remote area, how does this technology work?
The basic idea is the following, that most, not all, but most of diagnosis requires measuring something that's inside you. Yes, you can measure pulse, you can measure a few things like that completely non-invasively, but usually you need some blood, some saliva, some urine, something of that sort, and blood is the most diagnostic material. But in the developing world, you don't have syringes, you don't have vacuotaners and all the rest of the paraphernalia that's used in our healthcare system. About all you can hope for is a finger prick. So the idea is finger prick produces a small drop of blood. The drop of blood goes onto the chip. The blood circulates through filters and layers of paper and arrives in zones in which chemicals, reagents that are there indicate the presence or absence of whatever it is that you're looking for as part of the diagnosis, and change color or produce some other kind of signal. But it basically is something that has to work with as little human intervention as possible. And the trick is that. And
the interesting thing is, you know, you say changing color. Clearly, two of the greatest moments of my life, my wife waving the pregnancy test. Right. I'm pregnant. We're going to have kids. Right. And that's been around for a while. How come it took so long to get to this stage? Is it just...
That's a really quite interesting question. The pregnancy test and things of that sort have the characteristic that they really work quite well, and they're actually very inexpensive, but they're binary. That is, you're either pregnant or you're not pregnant, you're not somewhere in between, and there are many circumstances in which you want to know how sick you are or how well your liver is doing or your kidneys or whatever it might be. So they're not good for that. But the bigger problem is that why would you develop something that is very low cost in the United States where we have other ways of getting the same information also at very low cost and with very high accuracy? If you go to a doctor, there's a blood draw, the blood goes to a commercial diagnostic laboratory which has robots and automatic samplers. These machines do very well. They provide excellent data. They don't happen to work in Uganda or wherever it was that you used as your example.
Talk to me about vision and execution, because obviously when you're coming up with this, you have a vision of how it's going to work out in the real world and the impact it's going to have.
Right.
But then the execution part you have no control over. So if execution's going to go the way you want it to, I mean, what's your vision about how this changes healthcare in the developing world?
Let's first talk about money. Because when we started this, I was dumb as a post about much of this process. And I thought that, universities often come up with good ideas and then maybe a bit of an application, but we usually sort of drop out at that point and assume that somebody else will do it. I thought that we'd go further. We'd think about a product, something that would be a postage chip-sized device, and we had a good idea of how to make it inexpensive, and we thought that would be a big step forward. I think it is. It works technically very well. However, it is not yet saving lives because it's not a commercial product. Why is it not? The answer is that if you look at each of these steps, the science, the invention, the sort of engineering development that makes it work well and reliably and gets it through regulatory clearance, and then the final step of manufacturing, distribution, introduction to the market, and all the rest of that, the last step is dramatically more expensive than anything else. And the question is, where does the money come for that? And in the U.S., we have a system in which you think about these things, and big companies have lots of money that they could do this, but they don't have any particular interest in doing it in the United States. So understanding globally how you develop the capital to do these final steps is a genuine problem.
How do you push it?
Well, different people try different things. You can make an interesting argument that says that technology that works in the developing world actually should work in the United States in a different way. So one would use this not for our end-of-life model, but for something which would be a public health model, in which one thinks about monitoring health lifelong in some appropriate way to help you stay healthy, rather than trying to fix it at the end, because it's usually better to try to stay that way.
Is there any way that you can influence that, or is that completely out of your realm?
It requires innovative ways of raising capital. And there are companies that are beginning to think about this for the reason that the largest growth in many markets is going to come in the developing world. That's where all the people are. So I think there is an argument that says, learn how to do it there, and there will be eventually markets there. And by the way, a technology that's cheap enough and simple enough and effective enough to use there can probably be used somewhere in the United States, even if you don't see quite where. So I'm actually very optimistic about it. But it's the innovation here, in a sense, will come in understanding the full cycle of development, not in just making a particular test. Because, as you say, we've had simple tests like the pregnancy test.
Let me ask you this as a final question. How do you define success? Because you're in a field where you mentioned the past isn't important to you, the future is, right, and you're constantly pushing that envelope and pushing it. How do you define success?
I think the answer to that is that I'm not going to be able to know whether it succeeds or not, because the idea is a better world for our grandchildren and other people's grandchildren. And here we want them to be healthy, we want them to have interesting jobs, we want them to be doing whatever. And in the developing world, you want children to have some of the same kinds of opportunities insofar as possible. So success is looking at death rates from sickle cell disease, from pneumonia, from infectious disease, and reducing those numbers. And of course, as you do that, the consequences are actually quite complicated, because if death rates from kids go down, then the necessity for having large families begins to go away. Countries can spend more of their resources on education. With education comes a decline in population. With decline in population or population growth comes less carbon being produced. I mean, it all ties together in a really much more complicated way than I can understand, but it's a good thing to do.
See, I told you were a thought leader. Just all that, watching that trail go was very interesting. George Whitesides, pleasure. Thanks so much.
Pleasure to be here.
Coming up next, we'll talk with one scientist who says the future of organ replacements will include manufacturing and perhaps even printing them.